Hi, it's Mr. Blatch here. So we're going to be looking at finding the nth term in a quadratic sequence here. So a bit like when we're finding the nth term for a linear sequence, the first thing we're going to need to do is just find the differences between each of these terms up here, okay? So what are we doing? So we're adding 7, we're adding 11, we're adding 15, and we're adding 19, okay? Now because these are not constant, we need to do that again, alright? So that's going to be 4, that's going to be 4, that's going to be 4. Excellent. So now that's constant. What I'm going to want is half of this, okay, which is 2. Alright, so what I'm actually going to get then is 2n squareds. So that's telling me something about the nth term expression. So next thing we need to do is need to build a little table. We're going to start that off with n. We're going to say n is 1, 2, 3. So that's just the position number of each of the numbers in the sequence. 1, 2, 3, 4, 5. Okay. So then we need to do n squared. Well, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Then what we're going to want to do is have the number up there that goes in front of the n squared. So I want that many n squareds. Okay, so that's just going to be 2 times 1 is 2, 2 times 4 is 8, 2 times 9 is 18. Then I'm going to want the sequence, so they're just the numbers that I started with, so that's 3, 10, 21. All right. So now I'm going to want the difference. Okay, so this is as I go from here to here, right, how much more do I need? Alright, so what's the difference? So from 2 to 3 I need another 1, okay? 8 to 10 I need another 2, 18 to 21 I need another 3. Okie dokie. So now what I need to do is just find out what the differences are here. Alright, so realistically, because we've taken the n squared term out, the rest of this should just be a linear problem, a linear sequence problem, okay? So how much are we adding? We're adding add 1, add 1. So that is telling us that I've got 1n, or n. Yep. And what's the first number in the 1 times table? It's 1, isn't it? Okay, so how do I go from 1 to 1? I have plus 0. Alright, so throw that away really. So what we've got going on here is we've got Tn, so the term n, so any old term, is equal to 2n squared and an n and a 0, but we don't write that down. Okay, so that's us done. Okay, so we're in example 2 now. So we've got another sequence here. Let's find the differences between each of the terms. So that's going to be 7, isn't it? That's going to be 13. That's going to be 19. That's going to be 25. They're not constant, so it's definitely not a linear problem. So that's going to be add 6. That's going to be add 6. That's going to be add 6. So now that's constant. This is good. So what I want is half of this, okay, which is 3. So this is telling me that I've got 3n squareds. So that's part of the problem, a good chunk of the problem in fact. So then we need to build our table like before. So we've got n is 1, 2, 3, n squared is 1, 4, 9, and then what was the number in front of the n squared? That's the 3, so I need 3 lots of n squared. Well, that's just going to be 3, 12, 27. Now I need the sequence numbers, whatever they are, so that's 0, 7, 20. Right, now I'm going to want the difference. Okay, so I'm going this way. How do I go from 3 to 0? I take away 3, right? How do I go from 12 to 7? I take away 5. How do I go from 27 to 20? I take away 7, okay? So this is basically a linear problem now, isn't it? So just need to do like a linear sequence type difference here. So how do I go from minus 3 to minus 5? That's minus 2. Minus 5 to minus 7 is another minus 2. So that is telling me I've got minus 2 n's. What's the first number in the minus 2 times table? It's minus 2. How do I go from minus 2 to minus 3? I take away 1. Okay, so that's everything I now need to know. So the answer to the problem is Tn is equal to this bit, 3n squared, this bit, so that's minus 2n, and then the last bit up there, minus 1, okay? And we're done. Okay, so we're on example 3 now. If you're doing the Hegde clip, you don't really need to know this level of detail. This is like the extension, the exam question extension, okay? So we've got a few decimals in this one. So the question is, what's the initial difference between the numbers? So we just need to find that out. So how do we go from 2.5 to 4? Well, we're going to add 1.5. How do we go from 4 to 6.5? We add 2.5. How do we go from 6.5 to 10? We add 3.5. How do we go from 10 to 14.5? We add 4.5. Okay, they're not constants, so it can't be linear problems. We just need to do another level of difference. How are we going from 1.5 to 2.5? Add 1. 2.5 to 3.5? Add 1. 3.5 to 4.5? Add 1. So, like before, what we need is half this, okay? So half of that is 0.5. Now this tells us that what we've actually got going on here is 0.5n squared, okay? So we do our little table again, so we need our n numbers, don't we? So n is 1, 2, 3, n squared be 1, 4, 9. What was our number? So it was 0.5. So what 0.5n squareds? Well, that's going to be 0.5, so half of that's 2, half of that's 4.5. So now I want my sequence numbers, don't I? So that's 2.5, 4, 6.5. Now I need my differences. So how do I go from 0.5 to 2.5? I need another 2, 2 to 4, I need another 2, 4.5 to 6.5, I need another 2. So because we've taken out the n squared bit at this point, we should just now be left with a sort of linear, standard linear type problem. Okay, so what are the differences here? 0, 0. So that's telling me I've got 0n. What's the first number in the 0 times table? So the first number in the 0 times table is 0. How do I go from 0 to 2? I have to add 2, right? So now we've got our answer. So Tn, so any term n is equal to 0.5n squareds. Add 0n, but you know, that's not worth anything, so we won't bother. Add 2. And we're done.